In this work, we consider the Port-Hamiltonian interaction control problem of an aerial robot. The aerial robot considered in this work is a fully actuated hexarotor. Compared to under-actuated multi-rotor vehicles, this robot can perform more complicated tasks since it can reject an arbitrary interaction wrench. The interaction control technique used is impedance control, which in this work consists of a virtual spatial spring connected between the robot's end effector and the commanded desired configuration. A virtual linear damper is also connected between the inertial frame and the robot's body frame to damp its motion. We augment the impedance controller by an observer-based wrench controller to regulate the interaction wrench between the aerial robot and the environment. The overall system specificity is guaranteed by using so-called energy tanks. This is done by routing actively damped energy in the controller to a virtual tank. Then this stored energy is used to perform the non-passive action. The proposed control scheme has been tested in several experiments. In the first experiment, the hexarotor interacts with the force-torque sensor that provides measurements of the actual interaction wrench. In phase 1, the hexarotor approaches the sensor manually. In phase 2, contact is established using the impedance controller. Then in phase 3, the wrench controller is turned on. The robot is first commanded to apply 5 newtons of force to the environment. This commanded force is gradually increased until it reaches 8 newtons, at which one of the rotors hits its lower limit and stops. To show this behavior in another situation, the robot in the second experiment interacts with a vertical surface. When the commanded force increases beyond 8 newtons, one of the rotors stops again, and the robot can be seen flying with 5 propellers. Other experiments show that the proposed control scheme allows to simultaneously control the orientation of the robot while regulating a desired force of 4 Newton to a vertical surface. Finally, a sliding task was tested using the proposed controller on both a vertical and inclined surface. Thanks to the robot's full activation, it was able to apply a desired wrench of 4 newtons and simultaneously regulate its position and orientation to slide along the two smooth surfaces as commanded.